they do that. But it says the first three terms in the sequence is 14,000, 12,600, 11,340. And then it says complete the recursively defined function. Well, this is the exact same problem that we just did, except now they give us the terms. So this is what, when n equals 1, this is n equals 2, this is n equals 3, and they want to know what is n when it equals 4. Well, it's the same thing, right? So our first term is just 14,000, and we're multiplying it by something. Now, because this is written differently, how do I find that something that it's multiplied by? Well, I could get a calculator out, and what you do is you take the previous term. I know it's geometric. Well, let's start there. Let's go through this like we don't know, like we haven't just done this problem. It says the first, I got to make a decision. It tells me it's a sequence, so it's either arithmetic or geometric. So the first thing I would do is I would say 14,000 minus 12,600. So the difference between 14,000 and 12,600 is 1,400, right? So then I would do 12,600 minus 11,340. So right away I realize it's not arithmetic. Why? Because here I subtract 1,400, right? And then here I subtract, what was it, 1,260 or something like that? Yeah. So because they're different numbers, there is no common difference. So this is not arithmetic. If they would have been the same number every time, then I would know that it's arithmetic, and then I would continue to subtract that number, whatever that number is. So this must be geometric. So now you do the same thing, but when you do the geometric, you got to do it slightly different. You're going to take I'm going to take this 12,600 and then divide it by 14,000. 0.9. Interesting. So what does that mean? So that means that to go from here to here, I multiplied by 0.9. Well, if it's a true geometric sequence, then I should get 0.9 when I take 11,340 and divide that by 12,600. Okay, so it's a true geometric in the sense that to get the next term, I'm multiplying the previous term by 0.9. So to get the next term, the fourth term, because they give us the first three, I'm just going to take this and multiply it by 0.9, right? So I'm going to take 11,340.
Teachers, please excuse the interruption. We have a pickup truck in the student parking lot with its lights on. It is yours to come to the office so we can go turn them off. Pickup truck in the student parking lot with its lights on.
I'm just going to leave that in the video. It's funny. All right, so now that gives me my 10,206. Now, another thing that's kind of frustrating to the students is they tend to like one way or the other. So in the last problem, we got the same answer, we did it different. In this problem, we got the same answer, we did it different. Well, sometimes kids get frustrated because you barely understand how to do one way, and then you're learning a different way, but it's really all the same thing. I think the benefit to that, and I use this a lot as a math teacher, and then when I do research in the summertime, I'll do the same problem 3 or 4 different ways, and if I get the same answer every time, then I know that my math is right. In other words, it's a great way to double check and make sure that you're doing it correctly. I also know what the explicit function of this is, so I would plug it into I would do the explicit function and see if that would give me the same fourth term. So that's a great way to kind of eliminate mistakes. By the way, we're still learning the process. This process looks different, but it's the same process. I'm looking for either a common ratio, which this one had, right? So remember that this 0.9 is the common ratio. That's the ratio from one term to the next is 0.9. Or I'm looking for a common difference. If there's a common difference, it's arithmetic. If there's a common ratio, it's geometric. And then I just go through this previous function, previous term multiplied by the common ratio, right? Multiplied by the common ratio to get the next term. And then if I want to know what the 24th term is, well, I'm not going to multiply 23 numbers by 0.9 to get the 24th term. I'll write the explicit function and I'll plug in 23 or 24, whatever term I'm looking for, and that'll give me the value. It seems like a lot, but it's not.